So a couple of strategies for getting the Gaussian elimination for this one. Our goal is to get zeros all in the bottom left-hand corner. So what we find, and I asked this last class, did any of you make a zero? Because I think this zero is probably the easiest to make first, the one that's in the square, red square. If you just add this row and this row, you get a zero there. And so that could be very tempting. But then later, when you try to do anything else, that zero goes away. And some of you said that happened to you. You had one of the zeros, and then you tried something else, and that zero goes away. So what we end up doing is we always try to get these two zeros first. Because what that does is it essentially, once I have those two zeros, can you see that down here we basically have a 2 by 2 that we just have to now get this 0 second. So if we can get these zeros first, then we can work on the green box and then just use those equations to get the next 0. So that will always be the solution. Even if it gets bigger and bigger and bigger, you always get the first column of zeros under this number first, and then the second column of zeros. And your mathematics is always easier to get those to be zeros if the number that you have in the top right-hand corner is a 1. So a couple ways I could get that to be a 1. I could divide my entire first equation by 3. That would make it a 1. But can you see that I would also get other fractions there? The easiest way to get a 1 in that top left-hand corner without changing numbers is just switch two rows. So if I switch row 2 and row 1, then all of those 1s are in the top. And now, how could I get rid of this 3? 3 minus 3 row 1s, right? If I take this one and minus 5 row 1s, I'd get rid of the 5. And so over here, I'll show both of those things at the same time. I'm going to take row 2 and subtract 3 row 1s. I'm going to take row 3 and I'm going to subtract 5 row 1s. Doing that will get me those two zeros that I was talking about. And now we just need to work in this smaller, right? This green box, I could slide it over there. Now we can, slide it a little bit more. There we go. Now in that section, I can work on ways to get my next 0. I might take my row 2, since it's a negative 1 there, and multiply it by a negative just to make numbers positive. Just because I like working with positive numbers better. And then to get this to be a 0, I could take row 3 and add 6 row 2s. That will make this a 0. And we've succeeded in getting zeros in that bottom left-hand corner. Now that we've got zeros in that bottom left-hand corner, we can set up our equation and solve for z. 38 z's would have to equal 190, so z would be 5. Plug that back into the second equation. 1y plus 7z is 32. And solve that y is equal to negative 3. And then plug both of those back into the first equation and find out that x is equal to 2. Write our solution as a coordinate. Now that you've tried this on your own, one of the things that I would do as a recommendation is each time that you do something to double check your math. Because you can go a long ways with the wrong numbers only to find out that they're wrong, and then trying to find your mistake working backwards can take also a long time. So every time I do something, first of all, I'm checking my answers as I go along. When I set up my matrix, sometimes, and I don't know if I'd recommend this, sometimes I write it right away, switching the order around. So I put this 1, 2, 3, 4 one as my top row right away. So I had that 1 in the top left-hand corner. You could have written it a different way, but then you probably, how many of you switched rows to get that 1 there? It just makes life easier because you can get this to be a 0 by taking row 2 minus 2 row 1s. This one to be a 0 by taking row 3 minus 3 row 1s. And we've succeeded in getting those zeros first. If you have those as zeros, you can check, did you have these as your numbers? If these weren't your numbers, then you've made a mental math error somewhere along the way. One of the best ways to practice these, it's not very hard to make your own equation. Like pick a value for x, pick a value for y, pick a value for z. 1, 2, 5. 1, 2, 3. Okay? Then randomly put things in front and actually figure out what the answers would be. If I picked 1, 2, 3, this would be 2 times 1, 5 times 2, minus 3. I'd write a 9 there. And you can make your own system where you know what the answer is supposed to be. And then, if you make a mistake, you can do mini checks along the way, because you know what y should be, you know what z should be, is minus 10y's minus 2z's equal to 14. You can check that as you go. So after getting those zeros, something that was really nice is this is already a 1. So now I can get row 3 plus 10 row 2's, and I get that to be a 0 as well. Ignore the next green boxes and circles around things. That's getting ready for the next part. Now in Gaussian elimination, you now have negative 72z's are equal to negative 216. So z would equal 3. Plug z equals 3 into the second line. 1y minus 7z is minus 23. You get y is equal to negative 2. Plug the z and the y into the first equation, and you get x is equal to 1. So that's going to be the end of our Gaussian elimination for today.